Abuelito. No battery.
Good morning, Mr. Cook.
Good morning. Hey, you've got a real loud voice. You sing with me?
I don't think I have a loud voice.
You don't think? I mean, you're coming through the speakers quite well.
Oh, maybe it's just because I don't have my mic or my camera plugged in, so it might just be picking up the audio better. Whenever I have my camera plugged in, I think my camera has a little microphone on it, so I have to talk like that. So,
well, it's perfect. We have somebody here, and it's Abel, and Abel has an endearing name in this class, and it's Abelito. So you got to sing with me. So I sing, you repeat. Abelito.
I'm not doing that to Abel.
Oh, come on. He's laughing. Oh, come on. You're not going to do that to him? He's like, oh, come on.
I can't do that to Abel.
Oh, he said he can't do it to the T. So I love you too much. Oh my gosh, huh? Oh man. So do your folks have like an endearing name for you?
No, I don't think so.
Oh no.
No, not really.
Yeah, they're your
whatever she wants to call me. Yeah, my mom pretty much just calls me whatever she wants to call me. She'll say different things every time.
Different things every time. Did any of you other guys have enduring names that your parents call you? You won't say? T-E-T-I, is it Teti? Why Teti? I don't get it.
Because I was waiting to pronounce my name when he was like a little baby.
Oh. He goes Teti. Yeah. but it's you hear. It's not even close. It's like we'd be like calling Randy George, like Georgie. You'd be like, what the hell, that's Randy. What the hell is that? Not even E. It has the same last syllable. No, it's like calling her David. David. What about you, Daniel? Do anybody y'all have an endearing name? Danny?
Huh?
Same question. Do you have any?
Do I have a name?
Like an endearing name that your parents call you? No? Huh. What do you guys think I call my daughter and son? Kids? Homo sapiens? Huh? Children. I call him boy and her girl. It's about as general as it gets. It's kind of like a rural thing, like you call everybody that's a kid, hey boy, hey girl, something like that, or sweetheart. If you like them and you know them, you might say sweetheart, and that's male, female. It doesn't make any difference at all. Baby, hey baby, or something. I mean, but it's not. It's more of it's pretty general. So Teti, I start calling you Teti. Teti, I believe it. What time is it? Guys, it's almost 8 o'clock. Oh my God, I'm freaking out. I almost opened up and expected advisory. I had advisory queued up, and we've got this short day. I'm terrified of of attendance this morning at 8 o'clock and people not being used to going to advisory. It's terrifying. And I'm even more terrified that we have 50 minutes. We've only had one lesson, and that really wasn't a lesson. That was, IA proposal, and we had a test. We have one grade for the quarter so far, and I have 50 minutes to introduce evolution. So I've broken it into two parts. We will not finish this today. Just heads up, we will not finish this today. So if you're watching the video today, do not expect to be able to finish. I'm going to wait until 8:01 to get started. Let everybody that is at least in here get logged in and we can get started. So Abuelito, waiting on you. Oh, I see you now. Caleb, you're in so far? Caleb, yeah, let's go. You here, you're here. Danny, you're here, and then we need Randy. Okay. Hey, George. Oh, okay. Do now. How many days until the IE proposal? Drop it in the chat. Yo. Drop it in the chat. Yeah. Drop it in the chat. Oh. How many days until the IA proposal? How many days until it is due? The initial proposal, not the final one. The initial one that you'll get feedback on from me. How many days? Okay. Okay, yeah, yeah, okay. Some of you guys are giving caveats to it. Okay, yeah, in counting today, some people are saying something counting today. Okay. Yeah, counting today, you guys are right. Good, I'm glad that you guys remember this. I'm glad that you guys remember this. Caleb, have you answered the do now yet? I'm sorry? Yeah, there's a do now. You have to get off your phone. I'm gonna be on that thing. I'm looking for your phone. How many days until the initial IA proposal is due? Do you know? No, So I need you off your phone paying attention. It is 14 days, including today. Yes, 14 days. So 13 days, not including today. All right, so we're going to go ahead and begin. Let me try to let all these other people in class. They're lagging. As soon as this last person clears that hurdle and their mic is on, I know they can hear me. I'm going to begin. Good morning, all you beautiful people. Yeah, we do. We have 14 days. So today we are not going to finish the lesson. There's no way to do this in essentially 45 minutes or 48 minutes, which is what we have. It's not going to happen. So I'm sorry to say this, but you're going to have homework. I'll make sure I show it to you before you leave. I need somebody to keep me on track. Last time, Randy saved my life and told me that class was over, and I was like, oh my God. I was going to stay on a little longer for you guys that were at home, but I know kids here have to change classes. I'm going to try to stay with it so that we can make sure that we are staying on track today. And I make sure that, so somebody set an alarm for 45 minutes, and I will make sure I have time to show you where your homework is. All right, so today it's an introduction to evolutions. We're just going to have more or less a history lesson, and then I'm going to get into something called radiometric dating. It's going to be a very basic overview, and we will pick up with radiometric dating when we come back. It's going to be important that you do pay attention. This is something that's kind of tricky. You can't tell me anything specific about the ACT. But on any practice ACT that you've ever had, do you remember a radiometric question? There usually is one about every other time. There usually is one about every other time. It doesn't have, not yesterday, not counting today. Do you remember a radiometric question on the ACT? Not counting yesterday, because you can't tell me anything about that. Does anybody ever remember one? No, wow. Oh, an example would be like, we're talking about the decay of an atom going from from an isotope to a normal state. They like to use those on the ACT. Whenever I taught this, I was able to teach this much sooner last year, and the kids were like, oh my God, I'm so glad that we did that lesson. I know I got a question right. It was one knowledge-based question. So if you're going to take it again in June, just kind of make sure that you're paying attention to this. It could be worth a point. So first things first, there were several Greek philosophers that just started talking about the idea of evolution. The two that we'll deal with today, if you guys are historian people, you like the liberal arts, this might be right up your alley. What do you think they thought? Do you think that Plato and Aristotle, do you think that they thought evolution was or was not occurring?
They thought the idea of, what was it called again? Forms was how it worked instead of evolution.
What do you mean?
I mean, they thought there were like some alternate dimension of perfect versions of everything, and the real, or not the real world, but the world we live in is just like a distorted copy of that.
Yes, you
More
are.
or less.
Yeah, essentially, you are correct, sir. So they really believed in two worlds. They believed in, like you were saying, like this ideal and eternal world and this illusionary world that was full of these perceptions. However, the one thing that they did argue, because they did argue whether organisms changed over time, is they said, you know, why would an organism change? It seems like everything is perfectly adapted to how it's behaving or the environment it lives in. And if you think about it, that really does make a lot of sense. Like if I were to think, does a bird evolving? Well, why would it, right? A bird, if you think about it in its most general form, it has wings, it flies, it has eyes where it can find food, has a beak to crack nuts, or if it's a bird of prey, tear prey, swallow prey, whatever. Everything seemingly fits exactly how it should fit in the world, right? It seems like it's perfectly adapted for how it should be at this moment in time. So they did not. And Aristotle, he also thought that, you know, species were perfect, and were literally permanent, perfect, did not evolve, and it would be counterproductive. So it would really be kind of pointless. However, Aristotle did think that there was what he called a scale of nature, that you could see complexity from simplicity to complexity, and I think that you guys could probably get that point. What would you guys consider to be a really simple organism? Super simple. And you can drop it in the chat. What do you think would be a really simple organism? So something that would be ridiculously simple. Hello. Okay, what about in here? So Randy, what would you consider to be a really simple organism? Well, bacteria would be about as simple as it gets and that we know of. What do you think about Aristotle, though? They didn't know anything about microorganisms. What do you think he was thinking when he was thinking simple to complex? Huh? What do you think? A snail, exactly. A snail, an ant, a worm. I got hit. I've always wondered, you know, like worms have these ridiculously small brains, if you could call it. It's more like a neural center. And you can imagine what a worm thinks like. And we have a lab that we'll do next year with worms. And they have to, and we're giving them different stimuli. You'll love it. It's a lot of fun. And I got hit in that truck and I went into worm mode. You know, like your computer will get shifted into worm, like safety mode. When I got hit by that truck for 2 days, I couldn't remember what I was doing 30, 40 minutes before that. I mean, I was totally concussed. And I think of it like worm mode. It's like whoa, 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 stimuli, turn left. I mean, that's kind of the mode I was in. You know, so obviously these people thought that they were pretty advanced. Nevertheless, these ideas persisted for a very long time. And the first person that you actually need to, and by the way, I've got these highlighted terms, and these are terms you need to write down and know. IB is a very particular about terminology, and they want you, I have found this term, natural theology, on the exam. You need to know what natural theology means. So this is your cue to take notes. So those kids that are in here, I see Daniel taking notes, excellent. We're going to have a quiz. I'm going to have to give you guys a quiz to get some grades next time. So I'm going to give you guys a quiz next class, and it could be very simple, but I'm probably going to make it a little more difficult. So I don't want you guys to just be able to look up a term online and just do easy get it. But along came this idea of natural theology. Do you guys know what the word theology means? Just theology? If you're a theologian?
It's the study of religious materials, right?
Yeah, it's a study of religious materials, a study of God. Like if you're somebody who is a theologian, you would be an imam or a priest or a pastor or a rabbi. You would be some sort of shaman of some sort. It is somebody who studies the nature of God or studies God. And you got to remember, look at Aristotle, and these guys were BC. And we're now almost 2,000, right at 2,000 years later, and we get this new idea start to crop up, and they built upon it. And it was people that studied nature. And this was probably one thing that really motivated me as a kid, and why I study biology today. As a kid, I was one of those, I took a lot of refuge from my house. My house wasn't a very safe place. So I spent a lot of time in the forest around my house, lived in the country. And I was always looking at, nature. It was safe there. It was easy. It was quiet. It was a peaceful place to be. And I was a very religious kid as a little child. And I was thinking, if I believe in God and I think God is responsible for all of this, geez, I need to pay attention to this, right? And that's what these guys were thinking as well. They were thinking like, to understand nature is to understand God. If God is the creator, then I understand the creation, then I can understand the creator. And that was a motivating factor for some of these early scientists. And this is who my daughter is actually named after, this person named Carolus Linnaeus. And Carolus Linnaeus, again, he said that he was going to study nature for the greater glory of God. He said God created and Linnaeus organized. And we're going to have an entire mini unit over this system. We're not going to deal with it too much. Just want to mention the classification system. It looks like this. You're probably very familiar with it. Kingdom, phylum, class, order, family, genus, species, or King Philip came over for great soup or soccer or whatever you want to call it. It's just this really nice way of organizing things. And we're going to study this in much detail beyond just morphology and like these physical characteristics. We're going to really go back to DNA when we do this. So this was the pretty important person that influenced Darwin. Darwin, looked at his work and said, organisms can be based on similarities. And DNA sequencing can do this much more precisely today, but back then they just had what they could go on. And it was a pretty neat idea. I mean, if you think about it, who looks more like their parents, but children? Well, you have similar characteristics of your parents because you are coming from your parents. So organisms that are more similarly designed, so to speak, is what they were thinking, should have these characteristics. They should be, maybe these things are related in some way because they share these characteristics. It's not a stretch for them to make that leap there. Today, though, we're really going to focus on fossils. I'm curious, how many of you guys have a, let me see, what do we call those things? Scrapbooks. Have a scrapbook. Nobody. Anybody there online have a scrapbook? Those things might be a little outdated. Yeah, you put pictures in it. You have lots. Okay, Randy, you tell me. Randy says she has lots of scrapbooks. So is your scrapbook a perfect representation of your life, or even a close representation of your life? Think of it like Instagram. Instagram is just like these little moments in time. So when we get to fossils as being evidence for evolution, I want you to think of it like a scrapbook. It is a weak piece of evidence. If you get an FRQ and they're asking you for evidence of evolution, and you have the fossil record, is fine to put down, but it's the weakest piece of evidence that you could ever find. Mainly because fossils have to occur in very specialized conditions. You're not taking a picture of all of your life, and the world isn't taking pictures of all organisms. Let's say I die today, and Randy says, I'm so glad Mr. Pope's gone. Just tosses butt out there in the courtyard. And what do you think is going to happen? She drags me out there and leaves me in the courtyard. I know it. She's vicious like this. She leaves me out in the courtyard. Do you think y'all are going to be able to find me next week? Why not? Bits of me. Bits of me. Daniel says nothing. Randy says bits of me. Why? What would happen to me if bits of me? What's going to happen? Eyes and nose are the first thing to go. Okay. Okay, so worms. Other people are saying I would decay. Other people are saying I would decompose. All right. Beyond decomposition, what's going to most likely happen to me before I even decompose? Somebody can come by and get me. Let's say nobody saw me. You drug my sorry butt out there at 5:30, 6 o'clock on Friday, and I stayed out in the courtyard all weekend. Nobody saw me. What do you think is going to happen to me? I'm going to start decomposing immediately. I get that. But the ground ain't going to eat me. The ground's not alive necessarily.
When you decompose,
Other than decomposition, what's most likely going to come by?
A predator or something to like come like eat the carcass.
I'm going to come right back to it. I'm trying to listen to Randy too. What's that? Oh, scavengers. Yeah, and this is what I think Dev was saying too.
Yeah, it was.
Yeah, you're gonna have a dog say delicious. Let's take a bite of this. A vulture come by, take a bite of this. A cat's gonna come by, take a little bit here. Once you get down to the bones, then squirrels are gonna start gnawing on my bones for phosphorus. When organisms perish, often they are not. They're not going to, their bodies aren't going to lie around. They're going to get disassembled by a lot of different organisms, and what's left will decompose. So I want you to take a look. What do you think this is? What is that? It's a shell. There you go. What about this? A beetle. What about this? A what?
oh wait, never mind. That's
Yeah, mosquito or something like it. A flying insect. There's a lot of different answers here. Flying insect, mosquito. What about this? Yeah, those are leaves. It's a fern. The cool thing about this is every one of these organisms has an exoskeleton of some sort. This one has a shell, which is technically an exoskeleton, but they have an exterior skeleton. And then you also have plants, and they don't have a skeleton, but they have cellulose. And cellulose will also leave these imprints behind. Now, they don't decompose fully. They get covered by some sort of sediment. There's some sort of flooding event, or there would be wind. There would be something that would cover these organisms and not allow them to fully decompose, or an organism to find them and eat them. And they leave these imprints behind. Everybody here that's in class, take a look at your fossils that you have on your desk. And when you look at them, show the kids after you've taken a look at on your camera, like show them what you've got. And I want everybody to tell me, what do you think these kids have? Everybody in class has a series of fossils on their desk. But you'll have to turn your camera on so they can see it. Don't hoard all the goodness. Huh? Hmm? I was just explaining this. Like the sediment will cover them. Well, show everybody else. So where do you guys, what do you think these are? What environment do you think they came from? I mean, especially you guys in class, because you can see them better than anybody, and they have more than just one. Like, what environment do you think these things came from? You only have one? Oh my God. Here, Pat, can you pass him more? Yeah, I got you. So what do you guys see? What environment? They're all coming actually from the same environment. Every one of these comes from the same environment. What environment do you think these came from? I don't know. I don't think it had a name. You can show them the tooth if you want to. I mean,
Yeah,
whose
the
tooth? I think.
ocean.
Oh, good job, Buckman. How did you know it was the ocean?
Because Randy's and Caleb's look like a shell.
Yeah, they're shells. Most of these. I mean, I think Randy's got a shark's tooth over there too. Abuelito, he's got a shark tooth. I think Daniel, you've got kind of the coolest one because that looked like that came from a shallow bay. I don't know if it's plants or if it's invertebrates. I don't know. You got a really kick butt one. I wish you guys were all here at class so you could all kind of take a look at all these. The coolest thing about that is, where do you think I collected these? People say, huh?
Tide pools?
People said tide pools, ocean. Randy said someplace really dry. Yeah, but what place do you think that is? Like a geographic location, like a place on a map, like a name of a place. Where do you think I found these? Oh, it could be anywhere in the DFW area. You are correct that it's a DFW area. I found them right here in Tarrant County. Some of them I found here on this campus. One student, hold on, Abuelito, I think you've got it. Let me see. Abuelito's about to show you one that one of the students last year, we went hunted fossils on campus one day. It's a snail of some species, but show them. Okay, in a moment he can show you guys. But we found these here. There were sharks right here in Arlington, right, where what would become Arlington. So one thing that we know about the world is that it changes. The environments are going to change. So if going back to this idea here, if organisms are permanent and perfect, then we've got a real issue because we know that environments change and they change really quickly. If they were perfect, they would still be here today. These things wouldn't be extinct in the first place. If something's perfect, it doesn't break. It's always going to exist. Things aren't perfectly adapted. And that's something that has become apparent. If we were perfectly adapted, you would have no problem. There would be no problems in the world, no disease, no nothing. We'd be impervious to any kind of trauma. We're not, we're fragile. So we're gonna get into this guy, and you do need to know this person as well. If it's in red, you wanna write it down. If you don't wanna write it down, don't cry to me next week when you get these quizzes and you don't know who these people are. There is a guy named Georges Cuvier. He's a French guy. He was a paleontologist. He's one of the people that would be considered the father of paleontology. And he studied literally fossils, the strata, and it freaked people out. People were unaware of these things at the time. And if you look at this, we're not talking about a long time ago. We're talking about fairly recent history, just within the last couple of hundred years that people started to uncover these ideas. And what he did is he said that life's history was recorded in something called strata. These layers. If you've ever driven along the highway, you've probably seen when you look down the side of a highway, especially in Grand Prairie, Southern Grand Prairie, that big hill that you cross going back to Cedar Hill, and so, you can see strata in there all the time, these rocks. And there are several people that were like, oh yeah, I know exactly what you're talking about. You'll see these layers of rock. And these are just like that scrapbook. This will be a picture or Instagram. This will be a week later, 2 months later, another, maybe a year later. They're just pictures in time. They don't represent the full truth, especially on Instagram. The more people try to make their life look cool, the less cool it is. Just kind of keep that in mind. The more you try, the more you're trying to hide. It's at least along way I see it most of the time. I believe I see my neighbor's Instagram posts, and then I see them, and I'm like, oh, that's about as real as the movies. Nevertheless, he said that fossils, the deeper you went, the older they were, which is not a stretch. I think most of us get that. That's not a stretch of the imagination. Here's a picture of the Grand Canyon. I was a year older, maybe a year and a half older than you. and I took this photo. I had to see the Grand Canyon. I had to get out of Texas. I had to go see the world. And I drove out there and I stood and I took up this picture, old picture. And you can see the older parts of the canyon are here and the younger parts of the canyon here. So I'm going to draw here. Where do you think dinosaurs, if I were going to look for dinosaur bones, where do you think I would find them? I'm going to put some numbers here. So let's say, where do you think I would find dinosaurs? What number, what layer do you think would dinosaurs would probably fit? Really? I don't have 7. So I've got about 1, 2, 3, 4, 5, 6, 7, 8. You guys put it out there for everybody. I've only got 8 of you guys so far. Wow. I'm really surprised at you guys. Most people are saying 6. Oh, it's so much higher. This would, I'd probably find a dinosaurs right about there. Dinosaurs are fairly recent history on Earth. The Earth is 4.5 billion years old, and dinosaurs went extinct about 165 million years ago. So yeah, I don't even know that if I dug this deep that I would find anything that even had an internal skeleton. Down here, you'd be finding it'd be like jellyfish, echinoderms. I mean, this is probably about there, around 2. You may even find some there at 1. They're still fairly recent history. Now, Cuvier also said that he documented succession. I don't know if you guys know what succession is, so let's do a little practice. What is succession? So succession, let me ask, Daniel, who is the president of the United States? Joe Biden. Who was the president before Joe Biden? I'm sorry? Donald Trump. Randy, who was before Donald Trump? And Caleb, who was before Obama? Abuelito? Abuelito, who was before Obama? Not quite. You're missing somebody. All right, those of you guys at home. Okay, we got Bush. Let's see how far you can go. We can take it back. It's Bush. Before Bush. Clinton. Before Clinton. Bush. Before Bush. Reagan. Okay, and then Gavin's killing it. Carter. Who's before? Let's watch Gavin. See how far you can take it, Gavin. Gavin before Carter. He probably is. All right, before Ford. Nixon. Nixon was president when I was born. So we go from, so how succession works is Ford successed Nixon, Carter successed Ford, and then Bush, no, excuse me, Reagan successed Carter. I was reading this. Reagan successed Carter, and then Bush. And there's all these levels of succession, and there's this, the people will succeed one another over and over and over and over and over. It's one thing taking over from another. So my children have succeeded me, and then I succeeded my parents. It's one thing taking over for another. So if you'll see this, you can kind of see a pattern. It looked like maybe these organisms, oh shoot, these organisms were taking over for one another. They're all these four-sided shapes, and maybe there was a relationship, but I don't know. We'll come back to that idea. It did seem like organisms, there was a slight succession. There was some similarity between these straight up, but there was definitely distinct differences. And finally, he did, again, notice this. The deeper you dig, the deeper he was digging, the more different organisms became. If I dug down into, 40 feet, I'm going to find things that were more dissimilar than if I dug 10 inches, because this was deeper in time. At the time, that wasn't something that we absolutely recognized, but we now recognize that today. The last thing that he came to recognize was that extinction was common. 99.9% of all the organisms that have ever lived are extinct. And also 99.9% of all the organisms that have ever lived have never reproduced. It's a very small fraction of the organisms that actually are born, actually reach adulthood. And the ones that actually reach adulthood, a very small fraction, will actually reproduce. It's a rare thing. Most organisms also go extinct. So death is common. It's something that's normal. But excuse me. Man, I ate cereal. I got a pecan in my throat. It's been kicking my butt all morning. He noticed that there was all these unique fossils in every strata. Now, I dug in the same strata for all these fossils they found. I can't dig too deep. I just went and chipped stuff right off the surface and to find all of these. And there's great places to find them. But he recognized that history was common, that all these things have died out through time. Not everything, but obviously most things have died out through time. But do you think he thought evolution was occurring? Put it in the chat. Do you think that Cuvier thought evolution was occurring? Drop in the chat, yes or no? Did Cuvier accept the idea of evolution? Yes or no? Okay, I got one. Thank you. Thank you. Keep it up. Keep it up. And I figured as much. It looks like it's a pretty uniform yes. But he did not. He did not. He advocated something called catastrophism. He said that every one of those extinction events was a localized event. You also have to consider the time that people were living. The most people at this particular time on Earth thought the world was 6,000 years old. So to even advocate it, it wouldn't even come into your head very easily, the idea that the world was very, was old. And to say something like that would be pretty scary. You don't want to say something like that to be ostracized from your community. Most people were very careful about what they thought and said, and that influenced and drove a lot of the thought that they had. And it does still you can still kind of imagine. Let's go back and look. Let's say that there was a localized event, it wiped out this species here, and then maybe this neighboring species that was sort of adapted to this area could move in and take its place. And then there was an event that wiped out these organisms. This organism is very similar to this one. Maybe the adaptations are very close. So this organism came in and filled in this one's place, and so on. They said he thought these were localized events until they started unearthing dinosaurs, and then everybody crapped their pants. Now I'm going to, Yeah, thank you. All right. I'm going to get to something called radiometric dating, and I'll pick up here next time. How many minutes do I have? 13 minutes. 15. Scared the Jesus out of me. Okay, radiometric dating. We need to talk about what this is, and this is going to be something that's going to be important. So let me explain something for a moment. This is kind of a review from earlier in the year. Remember, atoms have a nuclei, and carbon has an atomic number of 6. So I'm going to make these little circles. We'll fill these in. These are going to be the protons for carbon. I'm going to make these solid circles. And this is just a recommendation for you guys at home. I probably would try to write this down to really get this idea. Now you can lean back in your chair if you like and chill or look on your phone, and that's up to you, including those of you in here. But don't come and say, well, why didn't I do well at the very end of the quarter? No, I'm not talking to Abel. I think you recognize what I'm talking to. All right, so here I have 6 electrons, 6 protons, and 6 neutrons. There's 6 of everything. So this is going to be carbon. Now, we would call this carbon 12. We have 6 protons and we have 6 neutrons. They're there, and that's the atomic mass of this atom. That's where we're getting most of the mass. Now, if I were to draw carbon-14, it's going to be a little different. Again, these are going to be my neutrons. Let Jacob 1, 2, 3, 4, 5, 6, 7, 8. These are going to be protons. And now I'm going to put my did I say protons? I meant neutrons. I'll put here solid is a neutron, circle is a proton. Keep myself straight. Now we have a total of 14. Same number of electrons. I'm drawing a smaller version of this. I'm going to draw the inside shell. There we go. It's kind of a basic here. And this is going to be carbon-14. They're a little different. This is what is normal or typical. This is going to be the stable form of carbon, and this is going to make up most of the carbon in your body. This is an isotope, and it is going to be radioactive. Now, this is a pretty basic idea. Carbon-12, carbon-14. If you haven't taken this down, take a quick snapshot with your with your phone, take a picture of it, and you can come back and you can get this idea in a little while. I'll pause here for about 10 seconds. You guys are pretty quick on your phones. I see you get them out all the time. All right, so let's take an organism here. So let's make a happy plant. This is a happy tree. What's that guy's name? Bob. This is going to be Abelito. Let's draw Abel. There's Abel. Do what? This is what Abel looks like. Looking at his computer feverishly. This is Abelito's computer. Nice. He's like, whoa, I'm amazed. I am. Okay. There's Abelito looking at his computer. Now, I'm going to get rid of his computer. Let's get rid of Abelito's computer for just a second. Abelito likes to eat. What'd you eat for breakfast, Abelito? French toast sticks. Delicious. Everybody wants some French toast sticks. Now, that's a plant. So Abelito eats some French toast sticks. They've got little syrup dripping off of them. Nice. So these are going to be sugars. He's got his French toast. I got my French toast, baby. Nice. I got my French toast. Now, all of these are going to have carbohydrates, right? These are going to be carbs from a tree. So they're going to have carbon. Mostly carbon-12, but there's going to be some carbon-14. Let's say that it's going to be, I don't know, let's say it's 99% carbon-12, just hypothetically speaking, and carbon-14 is only going to be 1% of this. Okay, so Abelito eats this. Nice, he eats it. And then Abelito is going to release some of this carbon. Now, that's going to be through respiration. So he's going to release some of that CO2. And in that CO2, it's going to be 99% carbon-12. It's going to be 1% carbon-14. And I'm really trying to set a stage for something that you have to understand when we do some math. So really pay attention to this little analogy and rewatch this video over the weekend. It'll help. And again, this idea is tested on the ACT as well. How else do you get rid of carbon, Abelito? What else is going to happen to this food? Some of it you're going to release as gas. What about the rest of it? Okay, that'd be gas. Some of it you might get rid of in solid form.
Oh.
Okay, well, we're going to ignore the rest of it, but you probably get it, right? Abelito's sweating a little bit. He's got a little, oh, hold on, I'm sweating it out a little bit. Oh, Jesus. You might actually, you might actually pinch one every once in a while. I don't know about how often, but let's hope it's a fairly regular pace. So other ways that you get rid of this abuelito is, yeah, a nice ripe one, right? Nice. It's got little eyes on it. Roger that. Smells real good. Whew. Now, this also is going to be 99% carbon 12 and 1%. And it's not exactly 1%. I'm just making a clear example. This is what we call an open system. Okie doke. This is an open system. You are taking in matter. So there is matter in and there is matter out. This is an important idea. Now, I'm going to get rid of you, Abuelito. I'm so sorry. Bye, Abuelito. Oh. Bye, Abuelito. Your sweat. Let's leave his sweat there so we knew that what he was up to. There's a little bit of sweat involved here. And that's pretty tough. I don't know. Maybe you're sweating that. You eat a little more fiber in your life, baby. Eat some apples. You need some apples, Abuelito. There's sugar in the apples too. Whole apples with cellulose to give you a little scrubbing effect. Yeah, there you go. Get your apple at lunch today. Let's get rid of this toilet. How do you say the toilet? Oh, okay. Nice. All right. We probably should have left that poop actually there, but I want to get back to a new idea here. If I could ever get this off, boy, this erase function on this tool is pretty bad. It's pretty bad. I wish there was another way to make this faster. All right, let's think about this. So here's my fossil. You guys have a fossil. So there's a shark tooth. These kids have a shark tooth on their desk. Here's a shark tooth. Now, at one time, this was part of an animal. It was alive. But now, is this shark tooth eating anymore? No, it's not eating. So no matter in is matter coming out? Yeah, slowly. There's some matter. There is going to be matter out. There's going to be some matter that is out. So I'm going to now there's no matter coming in. So this is a pretty important idea. So since there's no matter coming in, there is going to be matter coming out. Now, isotopes are going to be stabilizing. We have to get, so carbon 14, carbon 12, and carbon 14, the ratio of that is going to change. Where it was 99% carbon 12, which is stable before, and 1% carbon 14, this is before. Over time, radioactive carbon 14 turns into radioactive carbon 12. So let's say 20 years later, not even 20, let's say 20,000 years later, that ratio could be 99.9% carbon 12, and it would be 0.01% carbon 14. It would be much lower percentage. Carbon 12 is going to, is stable. It's not going to change. Carbon 14 is going to lose this proton. These protons are going to come out. These protons here, not protons, I keep misstating that all day. These neutrons, I'm sorry, you guys correct me if I make a mistake. These neutrons are going to stabilize, and you should get to 6 and 6. Right now, we are going to be at 8 neutrons and 6 protons. Carbon 14 will stabilize into carbon 12. And this gives us something called radiometric dating. Let me give you kind of an example of how this works. And I'm going to stop. I do not want to go any further. Let me show you what your homework is. And we will pick up here. There's no point in trying to get into this. This gets complicated. So please rewatch this video. Please do that. I hope I was mildly entertaining. Mildly. I'm not talking about a lot. I needed to kind of push through a little bit. Everybody's stretching in here going, thank God he shut up. You have some, this is the online document, and there's another one that I'm obscuring. I think it's a good idea that you guys work on these. Maybe if you want to get together over the weekend and work on these, you can. Only go to number 7. Do not go beyond number 7. The chances that you do it correctly beyond number 7 is going to be low. I want you to fight through this, think about this, and have this ready when we come back so that you can just open it and save it on your computer, turn it into a Google Doc if you want, and then you guys are going to work on this. But do not attempt number 8. I still need to go over how radiometric dating works before you figure out number 8, okay? So please don't go any further. It's not too bad. Also, there is some reading. Oh, you couldn't see that. Oh, well, crap, man. Y'all. Oh, well, Jesus, I'm so sorry. Y'all are all like, Mr. Pope's lost his friggin' mind. Sorry. Okay. Open, this is Fossils worksheet online. Sorry. You're like, oh, I see this. Number 1, 2, just to make sure you guys are on on your way. You might have to go back to 6th grade, 7th grade, 8th grade to kind of remember what the rock cycle. I mean, it's kind of basic. You probably remember this, but there's some rock cycle stuff here. If you're kind of struggling on this, look up the rock cycle. It'll be easy. You'll be like, oh yeah, I forgot about that. But don't go beyond number 7. By the way, there's read the whole thing and you could probably figure this out. There's actually something else in this for you to think about to help you with number 7. Number 8, don't even think about it, okay? I need to explain more before you guys tackle number 8. If you might mess with it, that's fine, but don't worry too much about it. About a third of you guys will understand, and 2/3 of you guys are going to be like, what is this guy talking about? And the other third of you will think you know what you're talking about, and you won't understand it as well as you think you do. And there's nothing more dangerous than somebody working on something where they think they know everything about it, but they're too ignorant to understand that they're wrong. And I'm not trying to castigate anybody. I'm just saying you might want to just hold off on number 8 so you can have absolute clarity so you don't reinforce bad ideas. And then that's it. It's not much. Now, there is reading. Let me go back to the reading. Goodness, that friggin' thing is good. There we go. Let's see. The reading is pretty helpful. Let me go back to the agenda today. This is everything that I thought we would do if we had a 70-minute class. The reading is no big deal. It's 5 pages. And I think I'd asked you guys to read this last time. There will be a quiz at the end of the next class. It'll be at the end of the next class, not at the beginning, because I don't expect you to understand this until at the end of it. But you're going to need to read and be ready for this. Last thing before you guys leave, we got 1 minute. On a scale of 1 to 10, how was yesterday? And as soon as you put it in the chat, you guys can bounce, and I will see you guys next week. No, just like how you felt about it. No school on Friday. Yeah. We'll see you guys next week. Friday is Good Friday. I'm going to go see my sister. I haven't seen my sister in over a year and a half. Oh my God. I agree with you, Keaton. I got to interact with human life. Would do it again. I'd do it again too. It's nice. Poor Amarani. She keeps getting kicked out. I wish she'd come to class and be here with us. Bye, babies. You guys be good. I'm sorry I talked the whole time, but we had to punch through this. We could not sit around and fart around with this. You guys be good. Play in the street. All right, you guys clean your desk and let's roll. What?
Good question.
Yeah, yes, it is. Oh, nothing. I couldn't find your answer. I like that, because I never figured out exactly what. My mom called me. Yeah, that's not a bad idea, except the worms will not, fossilize very well. Cellulose fossilizes better. Caleb, don't use. So I can imagine that.
Bro.
The bells aren't gonna ring, so as soon as you clean your desk, you can quit. I was playing for a moment.